Hey everyone. Hey Dinesh, how are you doing?
All good, all good. How are you, Eric?
I'm doing very well. Thank you for joining us today. Hey everyone watching our AMA today. First, just want to thank the audience for taking the time out of your busy day to join us. We've got a really exciting ecosystem partner in Flare Network joining us for what I'm sure is going to be an engaging talk today. For those of you that don't know me, I am Eric Vreeland, and I am the Chief Strategy Officer at Polyhedra. I'm joined by Dinesh Pinto, Technical Product Lead at Flare, and really pumped that you could join us today, Dinesh.
Yeah, very happy to be here. I can briefly introduce myself. Thanks for that. I'm Dinesh. I'm the technical product lead at Flare. Before working at Flare, I worked for some time at in Masari, and before that, I did my PhD specializing in quantum computing. And today, I'll briefly go into like a high-level overview of what Flare is, why Flare exists, what we're trying to solve in this space, and then we can, I think, get into maybe some questions after that. How does that sound?
Absolutely. Yeah, I think that's good. I think from my perspective, it's not just Flare's the Flare team's understanding of the importance of interoperability that made us excited to work with you guys, but also your diligent approach in evaluating the pros and cons of all of the different interoperability solutions that were out there, and your guys' interest in zero knowledge secured interoperability because of the traits that it brings as far as increased security and minimal trust assumptions. I know that recently there's been a lot of activity kind of ramping up on Flare, and so excited to hear more about what you guys are building, and of course after you give us a little more insight, opening it up to some questions from the audience. So I guess quick housekeeping. I'm going to turn it over to Dinesh for a quick presentation. I will hop back on for the Q&A portion. We encourage everyone in the audience to start sending questions in whenever they come to mind. I'll be keeping an eye on them and curating these questions throughout the hour. So keep them coming in. And with that, I will give Dinesh the stage, and you can take it from here.
Yep. Thanks, Eric. So I think I want to set the backstory a little bit and talk a little bit about oracles and more specifically the oracle problem. So one can kind of ask the question, like, why do we even need oracles in the first place? Aren't blockchains, don't they come with all batteries included? And the answer to that is basically no. A blockchain is fully aware of its own internal state, but it is not aware of anything outside of that. And a classic example of this is, let's take Ethereum. Ethereum, the blockchain, is not aware of the price of ETH/USD. That information is on all the different, centralized and decentralized exchanges. But the blockchain itself is not aware of that. And the goal of an oracle is to basically bridge this data gap between the blockchain and, let's say, the entire world that surrounds it. And if you look at the existing oracles that we have today, they do achieve this to some degree, but they leave a lot to be desired in terms of the security and the decentralization. If you look at some of them, some of the price feeds that these oracles are supporting have 5 data providers behind them, which is, in at least in my opinion, that's pretty that you can't really refer to that as being decentralized. Now, what Flare does here is Flare takes a slightly different approach. Flare enshrines the oracles into the blockchain itself. And what that means is that a validator on Flare doesn't just provide validity for the state transitions that are taking place. They're also a data provider for the oracles and an attestation provider as well. And I'll get into what those terms mean in a second. But the advantage of doing it this way is basically the network security is not just used to validate blocks, it's also used to secure the oracles as well, which means oracles inherit the entire security of the network. And this is in a, let's say, a very big contrast to third-party application oracles, where the oracle just lives on the application layer and it doesn't actually inherit any of the security of the network itself. So there are 2 main oracles on Flare. There is the Flare Time Series Oracle, or FTSO, And that is primarily designed for prices or feeds that are changing in time. So for example, you can take the price of BTC against USD. That's a constantly changing feed. So the FTSO is designed to handle use cases like that. And I'll talk a bit more a bit later about the upgraded FTSO V2 that was launched roughly about a week ago or so, which is quite an exciting development for us. The other oracle we have is FDC, or the Flare Data Connector. And the Flare Data Connector is a state oracle, which means it can read the state of other blockchains, and it can read the state of Web2 applications as well. So to take an example, if I have some Twitter post and I want to prove, does this Twitter post have more than 100 likes or not, I can ask the FDC to generate an attestation proof for that particular query that I make. And both of these protocols, both of these oracles are enshrined into Flare itself. So they're part of the core protocol of the blockchain. And utilizing both these core protocols is something called F-Assets, which is a trustless bridge that allows you to connect from Flare to non-smart contract chains like Bitcoin, for example. And on Flare, if you're a user, if you delegate or you stake your Flare, you're eligible for monthly Flare drops. There are 36 of them in total. There's still a long way to go. So there's plenty of reasons why to stay on and use Flare. If you're a developer, we have some very exciting stuff lined up on Flare. We have a bunch of hackathons coming up that I personally am very excited about. And the hackathon particularly that I'm excited about is the one that we'll be hosting with Google. So this is in collaboration with Google Cloud. It will be held in California in person, but you can also attend it virtually as well. We will support both in-person and virtual attendance. There'll be some very large prizes that we're giving away. And the focus of this hackathon is going to be on verifiable off-chain compute. And I think we'll probably get into the discussion as to why we exactly need verifiable off-chain compute and how it's connected to AI and all these different technologies as well. But there'll be three primary tracks. One track, of course, will be focusing on AI. So if you're an engineer, if you're a researcher in that space, this is a good opportunity maybe to play with things, win some prizes, and just try new stuff. There's also tracks on verifiable SQL queries, and there'll also be a more general track where you're kind of free to, let's say, if you're more interested in gaming, you can do that. If you're more interested in SocialFi, you can do that as well. So there's plenty of options for everyone involved. One thing, the slots are going to be limited for this. So I strongly recommend that you follow the Flare Network's Twitter account and maybe switch on notifications as well. So whenever that announcement goes live, you can then secure your slot as part of this hackathon. That's something that we are very excited about. So let me talk a little bit more about FTSO V2. So we recently upgraded the Flare time series oracle. So previously we were on V1, and V1 had some limitations. It limited the total number of feeds, the latency was limited, so on and so forth. With V2, we basically got rid of a lot of those limitations. So FTSO V2 can now support up to 1,000 feeds. It can also, it updates with every block on Flare, and the block time of Flare is roughly around 1.8 seconds. And it supports a whole range more feeds. So you can have cryptocurrencies, you can have equities, you can have commodities, and so on and so forth. And we have a bunch of target applications with this, things like perpetuals dexes, options dexes, futures markets, all these kinds of, and borrowing lending, of course, the most stable use case as well. All of these use cases are made possible on Flare with FTSO V2. And to kind of demonstrate, I'm going to do a live coding demo. Now, live coding demos are risky because things can often go quite wrong, but I hope this works. And what I'm going to show in this particular demonstration is just how easy it is to get started building on Flare and to build with FTSO V2. So right now I'm on the Flare Developer Hub. The address here is dev.flare.network. Make sure that you go to the right one. There are several scam links out there. Make sure you follow the address from the Flare Twitter account. And you can click on Get Started Building, FTSO V2, and Getting Started. And this is a sample contract. It's a very simple contract. And what it does is it reads the prices of three feeds. One is Flare, second is Bitcoin, and the third is Ethereum. And it does that in one single function call. So just basically this call over here is doing pretty much everything in this particular smart contract. And to test it out, we can now try this live. We can actually query the blockchain to see what the price is actually of these 3 feeds is. We click this button that says open in Remix. And what the Remix is it's a web IDE for Solidity. So you can basically compile and deploy your contracts from Remix. You can click the contract over here. You can see it's the same one. Just going to compile this contract. And now we can start deploying it. So I'm going to deploy this contract onto Flare testnet Costin 2 once my MetaMask loads up. And obviously, this is the risk of doing live deployments. For some reason, my MetaMask isn't loading. So okay, let's fix that real quick. Okay. There we go. Okay, so now we're connected to Flare testnet Costin 2, which is the chain ID of 114. I can deploy it in 1 click. So just click deploy. I pay whatever gas fees are required, which are extremely small. And now I'm just waiting for a green check mark to show up down here. That means the contract has now been deployed to the blockchain. Once it's deployed, I can see the contract over here, and I can now interact with it. Now, there's only one method on this contract because it is that simple. I can just click this button here. And over here, now I see the feed values for the prices of Flare USD, Bitcoin USD, and Ethereum USD, along with the metadata required to, let's say, use these prices in your decentralized application, such as the number of decibels and the timestamp of which the prices were last updated. So this is just like a little example of how easy it is to get started with FTSO V2. I think the whole process took probably less than a minute. I think the longer time was spent waiting for MetaMask to load up. So that's a very quick introduction to what Flare is and how easy it is to start building. And I guess I can now jump back with Eric, and we can maybe take a few questions from the audience.
Sure, absolutely. And maybe I guess to kick it off, maybe sharing a little alpha for the participants in the hackathon. What are some interesting applications that you think can take advantage of this functionality that are either, that you've seen are being built right now, or that maybe you hope will be built in the future?
Absolutely. I think the intersection of blockchain and AI, it's a very interesting intersection. There's also a lot of hype around it, which I'm honestly not the biggest fan of, because people obviously love to promise the world, but then deliver nothing. So I think when it comes to applications, we need to be thinking about how can this supplement what we have already built? Like, how can we use blockchain AI to build applications that are better than what we already have? And kind of a good example of that, I think, is under collateralized lending, right? When you think about lending as it stands today in crypto, I'm having to give 120% collateral to borrow 100%. That's pretty inefficient. And at least in the standard outside of crypto, that really wouldn't make a lot of sense, right? But if we can bring on-chain AI, and we can do it in a verifiable manner, which is, again, the goal of this hackathon, we can actually use the AI models to define risk metrics on a per user basis. And these risk metrics can then be fed into the protocol risk engine. So in this case, the borrowing lending platform risk engine, which can be used to dynamically adjust these parameters. So for example, if someone has a good history, they've taken a lot of loans, they've paid them all back, everything was on time, well, maybe you can start reducing their collateral ratios a little bit. So take it from 120, 110, 190. Someone doesn't do that, they stop paying their loans, well, now they're going to be at 150% maybe, because it's much riskier lending to them. Right. So I think this would be one of the very interesting ways where we can actually use AI, but make sure that everything is on chain and everything is kept verifiable. Other use cases, if we think about things like, let's say, gaming, right? To me, I think gaming and prediction markets are actually pretty closely related to one another. Prediction markets are kind of a type of game, right? And I think AI can play a role there as well, especially when it comes to settling more complex prediction markets. Because, of course, you have the simple prediction markets where it's just, oh, okay, this person won, that person didn't win. Fine, easy. I can just do that with the consensus mechanism, or I can use, there are multiple different ways that I can settle this market. But what about when markets start getting, more complicated, right? When they start getting more complicated, you need to inject nuance. You need to inject context into these systems. And this is, I think, where AI could play a very big role. Now, I do want to sort of throw a lot of caution to the wind, right? These things have the potential for going wrong quite badly, especially if we start, just blindly trusting in these systems. But that's really where kind of the blockchain aspect comes in. We don't have to have blind faith in the AI models. We can verify it, right? There'll be a full verifiability trace on-chain left by this, by the verifiable off-chain compute nature of these models. So I think these two are let's say, some of the biggest things that at least are on the top of my mind.
Amazing, and I totally agree. I think every week you're hearing about a new poly market that is up for dispute because it's not clear what the outcome actually was, and there's nuance there that then ends up going to some committee, which completely defeats the purpose of kind of why we're trying to build this on chain.
Exactly. And I think this is really where, sorry, I just want to add one more point over here, right? And this is a problem that exists in kind of AI as well, right? Like, how do you add nuance correctly? And if you look at the recent developments in AI, there's a lot of excitement around RAGs. So very simply speaking, an RAG can inject a specific context into an LLM, right? Now, what does that mean? So if I take a simple example, I want to add an AI chatbot to my website, right? Now, I don't want the chatbot to get information from everywhere else in the world, right? It's probably going to be wrong information. There's probably going to be some article that was published, a couple of years ago, outdated information, maybe even incorrect, right? I want to restrict the context of that model to just the website itself. And RAGs can do that. With an RAG, you can actually dynamically inject just the context that you want the AI model to use in that particular situation. So I think when you start thinking kind of in those terms, where you can actually restrict the behavior of AI, so it's not just unchained and left free kind of to hallucinate whatever it wants, you start to end up with much more robust systems that we actually are used to in crypto.
Yeah, it wasn't the intention of the conversation to go this way, but this is actually an area that we are looking into quite a lot, and we'll be rolling out, I think, product-specific chatbots and community-specific chatbots that are going to be, have this restricted knowledge base, so that, like you said, there aren't these hallucinations that answer questions kind of way from left field, and are really focused on, understanding the context that these questions are probably asked with regards to Polyhedra and one of our products, or something that could be answered by going to our knowledge base or our blog, or finding content that we've authored.
Precisely.
Okay, well, we'll take it down, kind of continuing on the AI train, because I think a lot of people find that interesting. Here's one question that we got from the audience: what are the key challenges in building truly decentralized AI infrastructure on top of a multi-chain network, and how do Flare smart contracts and Polyhedra's zkBridge address these challenges?
Yeah, I think when it comes to the challenges of building AI, you can probably break it down into three of them. The first one is going to be scalability, because AI is computationally very expensive. It's a very complex computation you need to do for these AI models. The next is data richness. AI needs data, and it doesn't need a little data. It needs an absolute, let's say, metric ton of data. And the third issue, I think, is probably going to be in terms of how can you ensure that you're running the model that you want to run on a particular AI network, right? Because different models have different behaviors. Like we talked a little bit about this context injection. How can I prove that the context was injected? What if someone just says, hey, I injected this context, but the model is not using it at all? And one of the solutions that we really want to explore, and this is part of the hackathon with Google that I mentioned earlier, are trusted execution environments. And the basic idea of a trusted execution environment, or a TEE, is it's a secure portion of a modern CPU or a GPU. And it's secured in such a way that the operating system, the kernel, for example, it's isolated from both of them. They can't actually read what is going on inside whatever's inside this trusted execution environment. And what you can do is, and this is a really interesting property of TEEs, you can request something known as a remote attestation from them. And a remote attestation will basically attest to a certain piece of code that was run on the TEE. So if I write a line of code, I can then prove that I wrote that line of code and that it ran on this particular TEE, right? So for example, I can say that, okay, I'm using Llama 3B, which is Meta's open source AI models. And I can actually prove that I ran Llama 3B, and I can get a verification of that proof from the trusted execution environment itself. And this is a hardware verification. So you can't actually, let's say, fake these verifications or forge them, right? And this is something that we're going to be exploring more and more with this hackathon.
Amazing. Here's another question, and you kind of answered this already a little bit earlier with your discussion around borrow lend, but how do you think that the integration of AI with blockchain will reshape industries like DeFi, gaming, and RWA tokenization?
Yeah, I think I talked a bit about the DeFi aspect with under collateralized lending. One can also think of things like more personalized services, right? Maybe a very, let's say, simple example of this. It doesn't actually need AI, but it does need powerful off-chain compute. Is fee tiers on Uniswap, right? Fee tiers are something that is standard across literally every single centralized exchange on the planet, but they don't exist on Uniswap, the biggest decentralized exchange. Well, the question is, why don't they exist? Well, if you actually try and compute every time a certain account has made a transaction, and you try and do it on the blockchain, I think someone ran some estimations for this. It's going to take you roughly around 10,000 blocks on Ethereum to do that, right? Which is pretty ridiculous. And those are full blocks, by the way. The entire block is just running one computation at the time, right, for one account. So obviously that's untenable. But if you move this complex computation to an off-chain entity, so something that is a verifiable off-chain like a trusted execution environment, or even a zero-knowledge coprocessor, which can also be used here, you can leave the blockchain to do what it's good at, getting consensus, maintaining trust, maintaining decentralization, and you still get all the verifiability guarantees from whatever compute was performed off-chain. So you can start to build these Web 2-like experiences. So in this case, it's a SEX-like experience that you're getting on a decentralized exchange.
Yeah, Dinesh, maybe you can give our audience a little breakdown as to how you think about TEEs versus ZK coprocessors, and like what are the advantages of one over the other?
Yeah, it's, I think, quite a nuanced topic, and we will probably start to get really into the weeds. And there's been a bit of discussion of this on CT, and it's always been framed as TEE versus ZK, who's better, right? Who wins at the end of this? And it's almost like one is going to win and the other one's just going to vanish away tomorrow. I take a very different approach to this one. The way I see it is each of these technologies has their strengths and it has their weaknesses, right? TEE can give you very high levels of performance. ZK can give you very, very high security guarantees. Why not combine the two, right? And this is actually what's happening. If you look at what the builders are doing, not the people arguing on Twitter, but what the builders are doing. They're building multi-prover models. So they're combining the properties of TEEs and ZK to build multi-provers for L2s. An example of this is Tycho, right? Automata Network is doing a multi-prover on EigenLayer as well. So you can actually pick and choose these. They don't have to be, fighting against each other. You can pick and choose the best properties you want from each of these different technologies.
I think that was a very good explanation. Hopefully the audience has a better grasp for how the difference between these two and also how they can be used together. Because like you said, I think we are seeing in our conversations a lot of teams that want to leverage both for their strengths and figuring out interesting ways to kind of combine those two technologies.
Yeah.
Okay, well, let's talk about let's shift away from AI a little bit and now focus on this idea of kind of multi-chain. So what opportunities do you think with the growth of multi-chain DeFi, what opportunities will the growth of multi-chain ecosystems create for DeFi, especially in areas like trading, predictions, and liquidity management?
Yeah, I think there will be quite a few opportunities. I think the primary one actually that we're seeing today is actually a standardization. And what I mean by this is something like layer 0 v2. Because when you think about what does layer 0 v2 do exactly, it's a standardization mechanism. You have the layer 0 v2 endpoints on different chains. And if I build an application on one chain, which is interacting with the layer 0 v2 endpoint, I can then take that application, move it to another chain, and it's interacting with the endpoint in exactly the same way, right? And this may seem like this is just part of the internal plumbing, it doesn't really matter. But this is actually how you build seamless user experiences. Because the internal plumbing is so well thought out, it's standardized, you can now spend much more time actually focusing on things like user experience, the actual UI of your product. What are users going to be facing at the end of the day? So to me, at least, the standardization with protocols like layer 0 v2 is actually one of the most sort of, let's say, interesting aspects of it. Also, I would like to talk about, let's say, zero knowledge proofs as well. We love zero knowledge proofs at Flare. We did a pretty extensive research on pretty much every bridge, I think, in this particular space. And we really liked Polyhedra's zkBridge, right? And there are two reasons for that. Number one is safety. With the ZK proof, you can't fake it, right? You get effective, as long as the ZK circuit has been implemented correctly, you can't fake a ZK proof. The second is liveness. For the Polyhedra ZK bridge, it has a 1 of n liveness assumption. And what that means is that you only need one node in the entire network, to be honest, for the bridge to continue functioning. So even if, let's say, you have 100 nodes and 99 of them are dishonest, doesn't matter. As long as one is honest, the bridge will function as it normally does. I think those are sort of amazing security properties and really aren't matched in this space. And that was really what got us quite excited about Polyhedra ZK bridge.
Awesome. Well, speaking of security, we've got a fresh question in from the audience. What makes Flare unique regarding the security of your data?
Yeah. So I touched upon this a little bit briefly. Flare's protocols, Flare's oracles, are enshrined into the network. What does that mean? That means that a validator on Flare doesn't just validate blocks, they also act as data providers for the oracle. And what that effectively translates to is all the stake security that Flare has, which is roughly around 67% of Flare's circulating supply, goes to both the block security and the oracle security as well. So they're both sharing that security. You can kind of think of it, if you're, let's say, more on the restaking side, you can think of enshrining as a stronger form of restaking. Because for enshrining, if you want to change an enshrined protocol, you got to hard fork the chain, because literally the protocol is part of the chain itself. With restaking, if you want to change the protocol, no hard fork is needed.
Got it. And so, so in this case, I guess validators could be slashed if they are incorrectly proposing blocks, but also if they are providing incorrect price data. Is that?
Yes, there are penalties for validators for both. For malicious block production and bad data provision. Yeah.
Got it. Very interesting. Let's see. I'm seeing some good questions in here. So, let's see. What challenges do you think exist in making AI-driven Web3 applications scalable and accessible to mainstream users?
So right now, the primary challenge is the amount of compute that's required to actually perform AI. So I actually mentioned 3 of these challenges. So the first one is scalability. How do we actually get the complex compute that's required by AI? Second is data richness. How do we get the huge amounts of data required by AI? And a third one, which you can also think about, is confidentiality, right? Let's say I'm dealing with some sensitive data. It could be things like healthcare data and so on. I maybe don't want to publish all that data to the blockchain, right? Because I want that data to remain private, especially if I'm like an institution or something. I want that data to remain private and remain confidential, right? The question then becomes is how do we solve all three of those problems, right? And I think verifiable off-chain compute, it allows for all three of them to be solved. You can get the level of scalability that you need to actually build AI without actually sacrificing any of the verifiability guarantees that you come to expect with Web3. So those are the three challenges, and that's a possible solution.
Okay, and going back to what you said earlier about when you were speaking to layer 0 and how easy it makes for application developers to build these multi-chain applications, how, if there is a change, does this change the developer's approach to building applications and coming up with the frameworks for these applications that span across multiple chains?
Mm-hmm. Yeah, I think the biggest change from an application developer standpoint is thinking multi-chain first. So you're not thinking in terms of, oh, I'm just going to launch on this one chain and I'm done and dusted, and now protocol is in whatever. I'm thinking of launching multi-chain. I'm thinking of trying to get users from different chains without having them to change the way that they want to experience Web3. Like, for example, if I have a user who really likes a certain L2, let's say Arbitrum, right? Why should they have to leave Arbitrum to use that particular application? Right? It doesn't really make a lot of sense. So I think developers now are starting to think sort of multi-chain first. But to think multi-chain first, you need the plumbing to be super efficient. Right? You can ask the question, why did they think multi-chain first like 5 years ago? Because the plumbing didn't exist. You couldn't think multi-chain at that point. So yeah, that's kind of the way I see developers reimagining how they want to go with multi-chain.
Got it. And for this next question, this might be going back to our TE discussion, but do you envision a future where AI models are hosted and trained entirely on decentralized networks like those
Yes.
Flare and Polyhedra? And can you speak a little bit more to what that future looks like?
Yeah, absolutely. I think that's definitely possible, and I think it may even happen sooner than what people may believe. Right? It's a hard challenge, but a lot of work has gone on over several years in this particular field, and I think it's definitely possible. What do we require for it? Well, we require a ton of compute and we require a ton of data, right? To give you an example of what kind of hardware you need for this, NVIDIA has the H100 chip, which is one of their most powerful chips that they've ever built, and that has a trusted execution environment on it, which means you can actually run verifiable AI models using an NVIDIA H100. Well, now you can think, okay, I have one NVIDIA H100. What's stopping me from having 100? Well, Flare is 100 data providers. Why can't they all run NVIDIA H100s, right? So I think we're not that far away.
Got it. And you piqued my interest a little bit, but would you, I guess, looking at the future roadmap of Flare, are you guys exploring ways to help support developers building on Flare with computational power?
Absolutely. I think that's going to be one of the more interesting aspects, where you're not just building an application that's data poor and low compute. And to kind of take a small example of this is OpenSea. Like, if you go to an OpenSea NFT listing, you can literally like count on one hand how many data points are actually from the blockchain. Right? Most of that data is in some off-chain computer that you have no idea where that data came from. Right? But if the chain itself can natively provide much more verifiable off-chain computing power, you could build an OpenSea with full verifiability guarantees with pretty much the entire web page being done in a verifiable way, and you don't have to rely on these random off-chain servers to do them anymore.
Awesome. Well, I'm also getting a few questions around, from people that are saying if they're interested in building an application with multi-chain functionality and launching on Flare, how did I think you showed earlier how to launch an application on Flare, but how did they take advantage of this multi-chain functionality?
Yeah, I think a great way would be a good example application. I can maybe take that one. The FTSO V2 example that I showed just now. Modify that smart contract. It's a pretty simple smart contract to send the data to the layer 0 endpoint on Flare. Select Polyhedra zkBridge as the DVN when you do that, and then send that data to any other chain in the world. Send it to Arbitrum, send it to Optimism, whatever you want. And now you basically have Flare's data sitting on a completely different chain, which is fully ZK secure because the bridge in between is Polyhedra zkBridge.
Absolutely, and that is where I was nudging you. I think we'll do a recap blog post of this, but check out the Flare documentation. Check out the Layer 0 documentation. As Dinesh said earlier, they make it incredibly easy to kind of build those pipelines between endpoints or between networks. And then if you are interested in getting the benefits of zero knowledge for security, it is extremely easy to configure your multi-chain application to utilize Polyhedra as the DVN to secure those cross-chain messages. So we're getting a lot of repeat questions here, Dinesh. I think we'll kind of start to wind it down, but is there anything else you'd like to share with the audience before we get out of here today?
Yeah, I think if people in the Polyhedra community or the Flare community, they're interested, you're developers, you want to start building applications. On Flare, you can go to the Flare Developer Hub, dev.flare.network. Also, make sure you follow Flare on Twitter if you're interested in the hackathon announcement. When that comes out, click on the notifications because, again, slots will be limited. There's probably going to be a bit of demand, so try and get in the front of that queue. But I think that's pretty much it from my side. Amazing.
Well, really appreciate you taking the time. Want to say thanks to everyone tuning in and asking these thoughtful questions. I learned a lot about what Flare is building today, and excited to see what the outcome of this hackathon is, because I'm sure there's going to be a lot of great stuff built at it. And you will continue to see, content and collaborations between the Flare and Polyhedra team in the future. So thanks again, Dinesh. Look forward to speaking to you soon.
Thanks a lot, Eric, for having me on. Yeah. See ya.
See ya. Talk to you later.